we're going to look at solving equations by factoring with some problem solving skills incorporated. Before I start with the application, let me come back up here. It's kind of an interesting thing. If you have a polynomial equation of degree 2, that means it has an exponent, the highest exponent is 2, kind of like this equation here. The highest exponent is a squared. It's going to have 0 to 2 solutions, and there'll be real solutions. If you have a polynomial equation of degree 3, that means the highest degree is a cubed, then you will have 0 to 3 solutions. And most of the ones that we'll see will have 2 solutions for squareds and 3 solutions for cubes. And that's kind of a nice thing to know so that you can tell what to expect when you finish your problem. Now on to the applications. A helicopter pilot drops his sunglasses while he's hovering at about 1,600 feet. And the height of the sunglasses, that's my h of t, so I'm going to write that down. H of t, that's the height. And t seconds, so my t by itself is time. And we have a function, h of t, so that's saying the height equals negative 16 times t squared, and t is our seconds here, plus 1,600. So this is our initial height from right here. It's put into this formula for us. So we want to know, when will the sunglasses hit the ground? So I want to know, how high are the sunglasses when they hit the ground? And if you think about how high is the ground is 0 feet. So we want to know at 0 feet, what is the time that it took? When is what we're trying to find. So the time is what we're trying to find. We don't know the time, but we do know the height. So we have a height of 0 feet and a time of unknown, and we want to use this equation to help us solve that. So instead of this height, the h of t, we're going to put in a 0. So I have 0 equals negative 16 t squared plus 1,600. Now if you think of this h of t, the whole thing is one little unit, and that it is also a variable, a single unknown, then it's going to help you quite a bit when you're using this function. This t on the right hand side is different, it's the time, and that's the one that we're trying to solve for at the moment. Now I have an equation that looks a lot like the quadratic equations I've been solving to this point, and it is already in standard form, set to 0. So the next thing I want to do is look on the right hand side and see if there's a greatest common factor. Now when I have these falling objects or thrown objects or dropped objects, I always want to look to see if I have a negative 16, if I can use that as my greatest common factor. And in this case I can, because it'll obviously go into this first term and it will also go into the second term. So when I pull out a negative 16, I have left in the parentheses t squared, and the 1,600 divided by 16 is going to be 100. And in between I have to have a negative, so that my negative here times negative here will give me a positive 1,600. Now inside the parentheses I've factored out a greatest common factor, so I want to continue factoring in the parentheses, and this looks like a difference of squares to me. It looks like I have t, obviously, is squared, and minus 10, which is being squared to give 100. So if I want to use my formula, if I have a difference of squares, I can write it as a plus b times the quantity a minus b. Now using that for this problem, if I'm factoring, I have negative 16, and it'll be t plus 10 times the quantity t minus 10. Now I have 3 factors multiplied, set equal to 0, so I can set each of those factors to 0. Negative 16 equals 0, t plus 10 equals 0, and t minus 10 equals 0. Now the negative 16 equals 0 is just garbage, because we know that negative 16 and 0 are not the same thing, so we will ignore that. The t plus 10 equals 0, I can just subtract 10 from both sides and get t equals negative 10. And when I think about what am I looking for, I'm trying to find time. Can I have a time of negative 10 seconds after I drop the sunglasses? And the answer is no. It has to be a positive if we're talking about time. So I'll ignore this answer also. It's an extraneous solution. And then on the very last one, add 10 to both sides. This is our last chance for a real answer, and I end up with t equals 10. And fortunately, I can have the sunglasses take 10 seconds to fall. So my answer is 10 seconds from a height of 1,600 feet. Okay, looking at the Pythagorean theorem, to use this theorem, we have to have a right triangle, which we usually show with a little box in the corner. And a right triangle means it has a 90-degree angle. And that would be this one that's represented by the box. The hypotenuse, remember, is the side opposite the right angle. And we always will call it C when we're using the Pythagorean theorem. The legs are the other two sides, and they touch the right angle. And they are A and B, and you can call this one A and this one B, or you can call this one A and this one B. So I usually just write it like that. Call one of them A, the other B. And then the Pythagorean theorem itself says that if you take A and square it, add B squared, it will equal C squared. So your hypotenuse is on its own on the right hand side, and the two legs are being squared and added together on the other side. So this is a Pythagorean theorem. And if we look at this word problem using a right triangle, we will need to use this Pythagorean theorem. So let's see what it says. The shorter leg of a right triangle, so right away I know I can draw a right triangle and one leg should be shorter than the other. The shorter leg is 3 centimeters less than the other leg. So I'll pick the longer leg and call it X. My shorter leg is 3 centimeters less, so I have to say whatever length this one was, X, take away 3, and I'll have the shorter leg. And then find the length of the two legs if the hypotenuse is 15 centimeters. So I know that my hypotenuse is 15 centimeters, and that of course is the one across from the right angle. So then I can use my formula. I have X squared for my A, and then I have plus this X minus 3. That's my B, so I'll square it, and that should be equal to the hypotenuse, or C, so it's 15 squared. Now, I'm looking at 15 squared, that's 225. I can go ahead and multiply that one out. The X squared, nothing's going to change, and I have to think for a minute, X minus 3 quantity squared, I really need to expand it and show the same thing being multiplied by itself 2 times, and then once I've expanded it, I can see I have to use FOIL to multiply it out. So I'll get X squared, and then negative 3X, another negative 3X, and a positive 9. And then I end up X squared minus 6X plus 9. Now if I had just squared the X and squared the negative 3, I would have gotten this X squared, and possibly I would have decided to get that positive 9, but I would have so been missing out on the negative 6X, and that's important, so we need to make sure we expand those. And then I'll just stick in this whole polynomial instead of my X minus 3 quantity squared. So I have plus X squared minus 6X plus 9. And then I can add my two X squareds together, and I have 2X squared minus 6X, and I have plus 9, but I also have a 225 over here. I know I need to move it to the left hand side so that I can have it set equal to 0. So subtract 225 from both sides. And I have quick calculator work here. I have negative 216 equals 0.